Okay, so 7.1, we are going to determine if a point is a solution, and then we're going to graph the linear inequalities that we get. So our first step is how do we determine if a point is a solution to a linear inequality? So your first step, you're going to evaluate the inequality for the given point, and that's just another way of saying substitute. So I'm going to give you an inequality with x's and y's, and then I'm going to give you a point. You plug in the x, you plug in the y, okay? The point is a solution if the inequality statement is true. So when we plug in our point, if we get a true statement, then yes, it is a solution. The point is not a solution if the inequality statement is false. So if it doesn't work and you get a false statement, it's not a solution. So let's look at our first example. I want you to determine whether 4,1 is a solution of the inequality 3x minus 2y is less than 2. So make sure that you write down the point. Make sure that you write down the inequality. You don't have to write all of the directions. Okay, so they give us a point which is x comma y, right? And they give us an inequality. So we're going to plug in 4 for the x, and we're going to plug in 1 for the y. So that gives you 3 times 4 minus 2 times 1 is less than 20. Okay, guys, what's 3 times 4? 12 minus 2 times 1? 2. And we want that to be less than 20. And 12 minus 2 gives us 10, which is less than 20. Is that true or false? True statement. So yes, the point is a solution. Okay. So yes, the point is a solution. So example 2, I want you to determine whether the point 4,8 is a solution to the inequality y is greater than or equal to 2x plus 1. Okay, guys, so what did you plug in right here for y? 8, good. And we wanted that, oops, wrong color. We wanted that to be greater than or equal to 2 times what? 4 plus 1. So that gives us 8 is greater than or equal to, what's 2 times 4? 8 plus 1. So 8 is greater than or equal to 9. True or false? False. So was this point a solution? No. So you would write no, the point is not a solution. Okay. Okay, so that was the first part of the standard, determine if a point is a solution. We did that, we mastered it, we're good. So now we're going to start graphing these things. So I need to give you a definition first. The vocabulary word is half plane, and a half plane is the graph of a linear inequality which takes up half of the coordinate plane. So whenever we're referring to half plane, it means that you're graphing an inequality, okay? And it's called a half plane because it takes up half of the coordinate plane. So the steps to graphing a linear inequality. First step, you are going to graph the line, just like normal, using either slope-intercept form, which was y equals mx plus b, or standard form, which was x and y on the same side. So whatever form that it's in, you're going to use that method to graph it. And you're going to graph it like normal. The only thing that's different is that we need to determine if the line should be a solid line or a dashed line. And a dashed line looks like this. How do you tell? If you have less than or equal to or greater than or equal to, that is a solid line because the line is part of the solution set. So if there's an equal to sign underneath it, you make a solid line. If your inequality is less than or greater than, you draw a dashed line because the line is not part of the solution set, so you can't touch it. It's kind of like doing a solid dot or an open dot on a number line. Then you are going to shade the appropriate half plane represented by the inequality. And how you do that is you are going to check the point 0, 0. If it is a solution, you shade the half plane that contains 0, 0. If it's not, then you shade the half that does not contain 0, 0. Okay, so you would shade the other part. Okay. Okay, so example 3, I want you to graph y is greater than 4x minus 6. So the first step, remember, is to graph using either slope-intercept form or standard form. So when you are looking at this inequality, y is greater than 4x minus 6, talk with the people in your groups. Does that look like it's in standard form, or does that look like it's in slope-intercept form? Okay, so this is in slope-intercept form because y is on one side of the inequality and x is on the other. So this is like y equals mx plus b, right? The only difference is that instead of an equal, we have an inequality. But other than that, it's exactly the same. So to graph this, remember, in slope-intercept form, we look at our y-intercept first. What is my y-intercept, guys? Negative 6. So you're going to go down 6 spaces for me. 1, 2, 3, 4, 5, 6, and put a point there. And then from there, we count our slope. Ladies and gentlemen, what is my slope? 4 or 4 over 1. So that means from our point, we're going to go up 1, 2, 3, 4 over 1. And how many points do I want you guys to do? 3. So we're going to go up 1, 2, 3, 4, right 1. So that should all 3 points make a line. Okay, now step 2, I'm going to pull it down really quick, says that we need to determine if the line should be solid or dashed. And if it was less than or equal to or greater than or equal to, that was a solid line. Less than or greater than, no equal to's, is a dashed line. So with this problem, should we have a solid or a dashed line? A dash. And the reason why we do a dashed line is because the equal to means that our solution can be on the line, meaning our point, we can pick a point on the line and it would give us a true statement just like in the previous example. A dash line means that it cannot lie on the line, so that's why we put a dash to indicate that you can't touch it. Okay. So then the last part is we need to decide which half plane to shade, and that we need to check the point what? 0, 0. So let's plug in 0, 0. Does anybody know why we plug in 0, 0? Because it's in the center. Any other reason? It's really easy to plug in. So this is going to give us 0 is greater than or equal to 0 minus 6. So that 0 is greater than negative 6. Let's think about this, guys. Is 0 greater than negative 6? Yes. So what this is saying, this point 0, 0 does lie in the solution. So the half plane that contains 0, 0, that's this plane that we shade. So we're going to shade this part that contains 0, 0. So you're going to shade in, and I do it with lines. You can shade however you want. The plane that contains 0, 0. If 0, 0 was not a solution, then we would shade the half plane that does not contain 0, 0. So the whole point of shading, guys, means that we can pick any point within the shaded area, and it would give us a true statement if we plug it into the inequality. So I could even pick, what's another point in the shaded area? How about 1, 1? Does 1, 1 lie within the shaded area? Okay, I'll plug it in really quick to show you. So 1 is greater than 4 times 1 minus 6. So that means 1 is greater than 5 minus 6, or I'm sorry, 4 minus 6. So 1 is greater than negative 2. Is that a true statement? Yes. So 1, 1 also lies within the solution. So any point in the shaded area should give us a true statement in the inequality. Does that make sense? So if 0, 0 did not work, that means that we would have had to shade the other half. We just pick 0, 0 because it's in the middle and it's easy to plug in. Okay? So example 4, I have y is greater than x plus 3. This one is also in slope-intercept form. So here's what I want you guys to do. With your groups, just graph the line for me So using y equals mx plus b, and determine if it should be a solid or a dashed line, and then we'll do the shading together. Okay, so just graph the line for me right now. Don't worry about the shading part. Okay, ladies and gentlemen, what is our y-intercept? Positive 3. So you're going to go up 1, 2, 3. What is your slope? 1 over 1. So you should go up 1 over 1, and then I'm going to go down 1, left 1. What type of line should this be? Dashed or solid? Dashed. How did you guys know? Because it's just greater than, there's no equal to. Okay, so I'm going to graph the dashed line. Everybody should look like this so far. Is that correct? Okay, so we need to determine then which area we need to shade, which half plane. So we're just going to check the point 0, 0. So that's 0 greater than 0 plus 3, which is 0 greater than 3. Is that true or false? False. So the point 0, 0, this point right here, does not lie within the solution. So do we shade that part? No, you need to shade the other part. So you're going to shade on top of the line. So if we were to pick a point in the shaded area, it should give us a true statement. So I'm just going to do it really quick. Do you guys, can somebody pick a point in the shaded area for me? What lies in the shaded area? 1, 2, 3, positive 4? Negative 4? 1, 2, 3, 4, negative 4 what? Positive 3, 1, 2, 3. Okay, so let's try negative 4, positive 3. So that's going to be 3 greater than negative 4 plus 3. So we want 3 to be greater than, negative 4 plus 3 is negative 1. Is that a true statement? 3 is greater than negative 1? Yes, and it does lie within the shaded area. Does that make sense? So what this is telling us is anything in the shaded area will give you a true statement, no matter which point you pick. We always pick 0, 0 to check because it's easy to plug in. Okay? So example 5, you guys are doing this all by yourself. We are going to graph y is less than or equal to negative 1/3 x plus 4. Here's your coordinate plane. Do the line, shade the correct area, and then we'll check our answers. Check it. So guys, what was your y-intercept in this case? Positive 4. So you should have gone up 1, 2, 3, 4. What was your slope in this one? Negative 1 over 3. So you're going to go down 1, right 3. But remember, you can also go the other way. So you also could have gone up 1 and left 1, 2, 3, just as long as you made one of them negative, either the top or the bottom. It does not matter. Is this a solid or a dashed line? Solid. And then when we 0, that's going to give me 0 less than or equal to negative 1/3 times 0 plus 4. What's negative 1/3 times 0, guys? 0. So that's going to be 0 plus 4, which is 4. Is 0 less than or equal to 4? Yes. So the point that contains 0, 0, is that shaded? Yes. So you should have shaded everything underneath the solid line. That entire half plane. Okay. Together. So example 6. I'm giving you a different form. Which form is this, guys? Standard form. So we have 2x minus y is less than 4. Now, you guys have two options. We can use x and y intercepts to graph this one, or we can put it in slope-intercept form. What do you guys want to do? Put it in slope-intercept? Okay, so to put this in slope-intercept, the first thing we're going to do is subtract 2x from both sides. So that would give me negative y is less than negative 2x plus 4. We did this right before the final. Now I need to get y by itself. So what would I have to divide by? -1. So to get the negative y into a positive y, I divide by -1. So that gives me positive y. Now who remembers what you do if you are dividing by a negative? You flip it. So this does not become a less than anymore. Now it is a greater than. -2 divided by -1 is positive 2x. And positive 4 divided by -1 is -4. So now we're in slope-intercept form. Okay. Okay, so this should be easy. We're going to go down 4, 1, 2, 3, 4. And we're going to go up 2, right 1. And I'm going to go down 2, left 1 again. Is this, guys, a solid or a dashed line? Dashed. And let's check the point 0, 0. So that's going to be, I'm going to check it over here to the right. 0 greater than 2 times 0 minus 4. So that 0 is greater than -4. True or false? True. So here's your point 0, 0. Since 0, 0 is a solution, the half plane that contains 0, 0 is all part of the solution. So that means we're going to shade the plane that has 0, 0 in it. So above that dashed line, everything above that dashed line is a solution. So we just check 0, 0 because it's easy. But you could check any point in that shaded area and it will give you a true statement. Here we go. Example 7. We're going to be decorating for the rally on Friday. And we want to use gold and blue paper. So gold paper costs $5 per roll. Blue paper costs $3 per roll. That's what I want you to write down. Gold paper is $5. Blue paper is $3. Your budget allows you to spend at most, so also write that, at most $48 per paper. That's all you need to write down. The question is, how many rolls of gold and blue paper can you buy without exceeding your budget? Okay, so part A. Write a linear inequality that describes the situation. We've actually done this. We did this in Unit 2 or Unit 1? Unit 1 or 2 test. So X is the number of rolls of blue paper. So how would I represent the cost of blue paper? X is just how many rolls. We need to multiply it by how much each roll costs. So what would we do? 3X, or X times 3. Now we also need to include how much we spent on gold paper. So that would be plus what? 5Y. Because gold paper costs $5 and Y is the number of rolls of gold. Okay, now here's where we need to think about it a little bit. Our budget allows us to spend at most $48. Can I spend more than $48? Can I spend $48? Yes, so that is going to be less than or equal to. Because we cannot spend more than $48. So we have to spend 48 or less. So less than or equal to 48. Let's graph this one. So I'm going to rewrite my inequality. And I'm going to put it in slope-intercept form. So what would be the first step of writing this in slope-intercept? Yeah, so let's subtract 3x. So that gives us 5y is less than or equal to negative 3x plus 48. And then to get y by itself, what are we going to do? Yeah, divide everything by 5. Now, do we have to flip the inequality? Because it's not what? Negative. So this is y less than or equal to negative 3 over 5x plus 48 over 5 doesn't reduce, so I just change it to a decimal and I punch it into the calculator and it gets you 9.6, okay? So to graph this, our y-intercept is 9.6, which is about 9.5. So I'm going to go up 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I need to go over. So I'm actually going to make each one worth 2. So this one is going to be 2, and this one is going to be 2. So we're going to go up 2, 4, 6, 8. Halfway is 9, and then 9.6 would be somewhere right here. And our slope is what, guys? Negative 3 over 5. So that means I'm going to go down 3 spaces. So each one was 2. So this is 2, and then one more is 3. And then 2, 4, 5 is right there in between. If you draw your graph with 1, do it with 1. Okay, but mine didn't have enough space. Okay, is this a solid line or a dashed line? Solid, so draw a solid line. And then let's use a little bit of logic. Do you think we're going to shade below the dashed line, or, I'm sorry, the solid line, or above the solid line? Below. Why do you think below? Yeah, because we have to spend less than that amount, right? So let's check it anyway. So I'm going to plug in 0, 0. So that's 0 less than or equal to negative 3 over 5 times 0 plus 9.6. So that's 0 less than or equal to 9.6. Is that true or false? 0 is less than or equal to 9.6. True or false? That's true. So we're going to shade the area that contains 0, 0, which is below the line. So you guys were right. Because we had to spend less than that amount. So then my question to you guys is, we need to find 3 possible solutions to the problem. Meaning, we need to find 3 points within that shaded area, because anything in the shaded area is a possible solution. So I'm going to do one. Let's say we want, does 2, 2 lie in the shaded area? So how about 2, 2? So 2 blue and 2 gold paper. Can you guys think of anything else that lies in the shaded area? 1, 1. Does 1, 1 lie in the shaded area? Mm-hmm. And then one more. Three, 3. Does 3, 3 lie in the shaded area, guys? Yes, it does. So we could buy 2 rolls of blue and 2 rolls of gold and still be within our budget. We could buy 1 of each and still be within our budget. We could buy 3 of each and still be within our budget. Could I buy 2, 4, and this is 2, 4, 6. What about 4, 6? Does that lie within our budget? Yeah, so it can be anything in the shaded area. Except, let's read this. The point negative 2, 5 is a solution of the inequality. So negative 2, positive 5, it's somewhere right here. Is it a solution to the problem? How many vote yes? How many of you vote no? Somebody besides Brittany, why no? Tom. Exactly. Is it a solution? No, because you can't have negative rolls of paper. So you also need to make sure that your solution makes sense, okay, especially with word problems. Okay? So there will be a question like that on your homework. So just make sure that your answer makes sense. Okay? That's inequalities in graphing.